Hello students, previously we have discussed the information about the mass and the weight and difference in between mass and weight. Here we are discussing the new concept, free fall. What is the definition of free fall? If we focus on the definition, we come to know a little things about the free fall. When object is released from the certain height, that means you have to maintain height first. Then it moves under the influence of gravity because earth will attract that object towards its center. So definitely will move downward. If it moves under the influence of gravity alone word play a very important role here. Such a falling is said to be a free fall of an object. Let me explain. See, this one is any planet or maybe it is earth. One object is on the surface of earth which is at rest because of inertia. If you want to change the position, within the first part of lesson we have discussed to change the position, to change the direction, to change the location, to change the velocity, to change the shape, we require force. And force is given upward. Suppose F force is given upward, then definitely the object will start to move upward and it reaches certain height according to given force. It will have the initial velocity. But when the object is moving upward, one more force is acting on that object, and that force is gravitational force which is downward. And because of this gravitational force which acting downward, the object's velocity starts to decrease. Because object is moving upward with its force, but one force is pulling it down, and so velocity goes on decreasing. As initial velocity is larger than the final, here acceleration is negative acceleration. And because of this negative acceleration, velocity of that thrown object starts to decrease, and at certain height, suppose this height is h, at this certain height the object will come to rest. And here now after that only one force, because your given force is negligible now, and only one force is acting on the object, and that force is gravitational force. And after that moment, now the object which is at rest starts to move down under the influence of gravity. Here initial velocity while coming down is 0. And when this object will come towards the center of earth, why? Because of gravitational force. Gravitational force is always towards the center of earth, vertically towards the center of earth. Now within the second movement, the object starts to move towards the center of earth, and it will come and collide with the surface definitely. Then here the object is falling down. Why? Because of this force of gravity, and such a movement of object under the influence of gravity, or only gravitational force is working on that one, such a fall of an object is called as free fall. See what is important factors within this free fall. Number one, initial velocity is 0. When object is going upward because of given force, and here gravitational force is acting on that one, it reaches at certain height, and after reaching certain height it becomes stationary. And when the object is stationary, then we consider velocity is 0, and then it starts to move downward. While moving downward, initially the object was at rest, and so we have considered at that time its initial velocity was 0. So always in the free fall, initial velocity is 0. Then what will happen? Second point is here, its velocity goes on increasing due to acceleration because of gravitational force. See what will happen. Now here object is at rest. Why? Because given force is now negligible. Whatever energy, because of given force, object having energy, and that energy has consumed to travel the distance. So energy 0. So now force is not acting on that object, and now because of no force given by outside, this object become raised to initial velocity 0. Now tell me, which forces are acting on that one? Only one now. Which is that force? The force exerted by the object, exerted by the earth or the planet on that object, and it is towards the center of this planet and vertically downward. So object starts to move downward. But we discuss this, as distance starts to decrease, force starts to increase, and so acceleration is positive acceleration. And because of positive acceleration, the initial velocity is definitely less and final velocity goes on increasing, and so within the free fall the object's velocity goes on increasing. What is the reason behind that one? Acceleration due to gravity, which is positive one. When object is moving downward, acceleration is positive. When object is moving upward, acceleration is negative. And so due to acceleration, due to gravity, its velocity starts to increase. See, again one important factor we should discuss, both the objects having the equal force. That means earth force to the object and object's force to the earth is same. But only why stone or that object is moving downward, it is depend on mass. So acceleration is inversely proportional to mass. Less the mass, more the acceleration. Less the mass, more the acceleration. More the mass, less the acceleration. Tell me, what should be the weight of this stone? Maybe 1 kg. But what about the weight of earth, that is the mass of earth? It is so high than the object. And because of that, less mass, more acceleration, and so the stone get accelerate and it starts to come down. Not earth is moving upward and get attached to the stone, because mass is less. So you see here, so what we have discussed here, initial velocity is u, that is always 0. Final velocity is indicated by v. Time taken. What is the time taken by the object to travel, cover the distance from that height to the surface? That time is considered as a t. Acceleration is actually a, but here we are discussing acceleration due to gravity, so we are considering that one as a g. And height, that is displacement. So whatever the height gained by the object, same height it will having as a displacement. So here displacement is equal to h. H is height and it will convert as a s as a displacement. So we know that in the 9th standard we have discussed 3 laws of motion given by the Newton. What are that? V is equal to u plus at. That is v velocity, final velocity, u initial velocity, a acceleration, t time taken to cover that distance. But see here how this first equation will change within free fall. Here v remains same. Acceleration here, initial velocity is always 0, so it get cancelled. So a is acceleration due to gravity and t is time. So this one is the first equation we are getting in the free fall, that is v is equal to gt. That means final velocity is equal to acceleration due to gravity into time. Second, s remains same, that is a displacement, that per height is equal to u 0, 0 into time get 0, and here 1/2 remains as it is, and acceleration here due to gravity and time square. So the second equation we are getting here, what is the second equation? S is equal to half of gt square. S displacement or distance traveled by the object, g acceleration due to gravity, t time, that is time square. The third equation, v, that is v square remains as it is. See here, u square, but value of u is 0 and 0 square is also 0. So 2 into acceleration, but here acceleration due to gravity, so 2gs That means v square is equal to 2gs, v final velocity, g acceleration due to gravity, and s displacement or the distance traveled by the object while falling down. As we have discussed, free fall is a falling of an object or a fall of an object under the influence of gravity alone. So why we have used this word alone? Definitely little problems are there. See, what are the problems? The first problem is frictional force due to air. When, see, this one is the surface of a planet, or consider here as Earth, and the object which is at height h, definitely it will travel the distance s, that is h. So here height is equal to displacement. When object is under the influence of gravity and coming downward, yes, this surface or this planet is surrounded by air, that is the atmosphere. And while traveling the object through the atmosphere, definitely the frictional force of air which is working upward, that means upward means what? Opposite to direction velocity of an object. So here object is not falling under the influence of gravity alone. Along with gravity, one opposite frictional force is working on that object. So can we call it as a free fall? No, actually it is not a free fall, because frictional force due to air is also working on that object. So it is not falling under the influence of gravity alone. Again one point is there, buoyant force. See, what is buoyant force? When any object, see this one is object, is immersed partially or totally. Now just within this portrait I have shown the object is partially immersed in the water. See, this one is water. And when the object is immersed partially in the liquid or air, definitely the force from this medium is get exerted on that object. And so it will not allow that object to get entered within that liquid easily. And so this is floating. So why objects float? That was the lesson we have discussed. Within that one, we have discussed this buoyant force. So buoyant force is always partially immersed object having the upward thrust. And so when object is falling towards the surface of Earth, this air, that means the gaseous medium and the liquid mediums, are considered as the fluids, and the fluids having force of buoyancy. And when object is moving downward towards the center of Earth, that means free fall under the influence of gravity alone, it was the requirement. But here buoyant force exerted by the atmosphere towards upward is also working on that object. So here is also only falling is not under the influence of gravity. Again one force is working on that object, that is buoyant force which is upward. So the object is not falling freely on the earth because of the atmosphere and because of these two forces. One is frictional force and second is buoyant force of the atmosphere. So where we can take this free fall, and free fall is only possible in vacuum, because in vacuum we do not observe this frictional force and the buoyant force. So truly free fall is only possible in vacuum. So maybe in examination there will be question. First question, free fall is only possible in vacuum. Explain. Free fall is not possible on earth. Free fall is not possible in air. The answer is same. Which is that one? When object is falling through the atmosphere, then it has to face frictional force due to air, which is opposite to the motion of the object, and the buoyant force given by the fluids, that is air, it is also opposite to the direction of the motion of the object towards the center of Earth, and due to frictional force and buoyant force, free fall is not possible on the Earth. Then where it is possible, this frictional force and buoyant force are not existing in the vacuum because of atmosphere. Particles are not there, and so free fall is only possible in the vacuum. Within this free fall, we have got three equations. Which are they? Which are related to motion, and we have derived this equation with the help of Newton's law of motion. The first is V is equal to gt, second is S is equal to 1/2 into gt square, and the third is V square is equal to U square plus 2gs. But here this U square will get cancelled and only it remains as the 2gs only. See now, the first question we are discussing now, and which is that first question. To estimate the height of the bridge over a river, a stone is dropped freely in river from the bridge. We are standing on the bridge, we have taken one stone and we are dropping that stone down in the river, but how it is? Freely. Consider it as freely. The stone takes 2 seconds to touch the water surface in the river. That means the time taken to travel the distance by the stone is 2 seconds. Then calculate the height of a bridge from the water level of the river. That is the question. See, first what is given. First of all, initial velocity in the free fall is always 0. And so initial velocity is equal to u is equal to 0. Second, the time taken they are given. The time taken by the stone to reach or to touch the water in the river is 2 seconds. So time taken t is equal to 2 seconds. Thirdly, acceleration due to gravity, it is near the surface of Earth. So we should consider that is 9.8 meter per second square. So that is all given. So what to find? To find height of a bridge from the water level within the river. Now, the displacement done by or the distance traveled by stone, that is the height of the bridge, and so we have considered height of bridge is equal to h, that is equal to s, and that is to find. See what we have. We having u, we having t, we having g, we have to find s. So only we having s, g and t. So what should be the formula we can use here? Second number formula we can use, because we have to find s, that is the height, g, h, then g having 9.8 and time is also having. So which formula should be selected? The second. So which formula we are using here? Height is equal to s, that is displacement, that is equal to half of g t square. So use that method. So h is equal to displacement is equal to half into gt square. Fill this value, that is equal to 1/2. Value of g is 9.8 into 2 square. So when we focus here, we are getting 1/2 into 4 into 9.8. We are getting here 2 into 9.8, and the final answer is this one. So it is a distance, so always measure in meter. So what should be the height of bridge from the surface of river water? Definitely the bridge is at the 19.6 meter from the surface of water. This one is the second example. See, a ball is thrown up with a speed of 15 meter per second. That means 15 meter per second is the initial velocity u. Here free fall is not there. Ball is going upward and the initial velocity is 15 meter. How high will it go before it begins to fall? after begins to fall, it will be rest or not? It will go up by decreasing the velocity. Velocity becomes 0, that is now V0. And while coming down, then initial velocity is 0. But here we should consider initial velocity 15 meter per second, final velocity 0, and acceleration due to gravity is 9.8 they have given. But while object is moving upward, acceleration due to gravity is negative. So value of g we should consider negative. So what height it will get? That is displacement. That is h is equal to s. See here, which equation we should use? We having displacement, we having acceleration due to gravity, and final velocity also we having, that is value of g we having. That is height we should find. Final velocity 0 we having. But here we should use the original formula because here free fall is not there. These equations are only for free fall. And this original equation is v square is equal to u square plus 2gs. That is as. Now u is 15 and v is 0. So let's fill this value. Which formula we are using here? V square is equal to u square plus 2gs. So, what is the value of V? 0. 0 square is 0. Value of U 15. 15 square 225. 2 into negative 9.8 because object is moving upward, acceleration is negative. So, negative 9.8 into 19.6 into h. So, as it all transferred to left side, it becomes positive. So, 19.6 into h is equal to 225. So 19.6 carry forward, denominator h is equal to 225 divided by 19.6, and final answer we are getting 11.4 meter. So how much height it will gain before falling down? That height is 11.4 meter. So the third example, a cricket ball is dropped from the height of 20 meter. Then calculate the speed of ball when it hits the ground and time taken to hit the ground, and when value of g is 10 meter per second square. So what we have? We have the initial velocity 0. Then the displacement height is 20 meter and value of g is 10 meter per second square. Then what to find? V. So see, to find V, G and S we having. So where is VGS? VGS. So to find first V, we are going to use this third formula, and after finding this V, we having V, G and S. So any one formula, V, G having, we can find D. Yes, G we will have, then we can find D. Any one. I will go for the first formula. See what is here. V square is equal to 2GS when object is falling freely. So V square is equal to 2 into G into S. 2, G value is 10, S value is 20. So here we are getting final answer 400. But see, don't forget this. It is V square. So V is equal to square root of 400. So V is equal to 20 meter per second. So when the ball will hit the ground, what will be the final velocity? It should be 20 meter per second. So go for the second one. What is the time consumed by ball to hit the ground? That is, we are using this formula V is equal to gt. So value of V is 20, value of G is 10 into T. Therefore, T is equal to 20 divided by 10, and final answer we are getting 2. So time taken by the ball to hit the ground is 2 seconds. That will be the final answer. So all this formula we have learned to use how to use this formula. So by this we have discussed the free fall. What are the formulas for free fall? What should be necessary for free fall? Initial velocity should be 0, and when object is falling down, final velocity goes on increasing. Free fall is not possible on the earth. It will be possible only in the vacuum because of two reasons. Because wherever we have in the atmosphere, there are two forces working opposite to that fall. Which are they? One is frictional force and second is buoyant force. And so free fall is only possible in the vacuum, and some examples based on free fall. Thank you.